Purple.
Blue.
Okay.
I wanted blue.
Lesson 100. Parabolas.
Smash, math, smash, math, math.
Any of you know what a parabola looks like?
Triangle.
Show me. At the same time, just show me.
Oh.
Okay.
Got it.
Look like that.
Yeah.
It can look like that.
Oh, of an umbrella.
Technically, it can look like this, or like this.
That's a C.
Wow.
We are not going to talk about these ones.
Good.
There are no sideways parabolas. There are no sideways parabolas.
But if you like tilt your head, that kind of
At least
sideways.
at least not in this class. Okay. So we have parabola is a shape. If you only look at part of it, it kind of looks like half a circle, except it just keeps going forever, never. And one of the main characteristics that we need to determine on a parabola is, does it open up or does it open down?
Oh.
And so that is going to be, yes, you're very certain.
What if it opens straight, like both sides?
No.
Open straight like this,
Yeah, that's the one I like.
that would be a line.
It's my favorite parabola. Blah.
You're my favorite parabola.
Oh.
Oh.
Okay.
Favorite too.
Alright, so one of the questions is, so one of the things we need to figure out is, does it open up? Yeah, what's this say? Open up, or does it open down? Now, if I were to graph something that looked like this, what shape is that?
A line.
A line. What type of equation does this gives us a graph like this?
Y plus mx plus b.
Yeah, you said plus here, you meant equals, but yeah, something like this. Tell me about the x variable in this equation.
Mm-hmm.
Well, it's an X with an M in front of it.
Okay, it's an x
Oh,
with some number in front of it. It's not an x squared, it's not an x cubed, it's not,
An XX.
we're not doing sine of x or square root of x or anything else. It's just one x.
1.
Okay, and then with the number, with the times the number in front of it. The way you get a parabola is, with an x squared.
Wow.
So this would be the most basic parabola you could possibly think of or graph. And what that looks like is, this comes down and touches, Yeah, I teach math, not art. Okay.
It looks like a set.
What if I draw this first? Aha! Close enough.
Kind of looks like a pitchfork with like a.
No, it's like Poseidon's, whatever the sea was.
That's called a pitchfork.
It's just a really thick x-axis. It's at 0, 0, okay?
Oh, okay. I see that.
Okay.
It's not a pitchfork.
Now, does that parabola open up or down? What do you think it might take to get a parabola to open
A
down?
negative.
Negative. What an excellent idea.
Negative.
Now the question is, where do we put the negative?
On the x squared.
If we want to take this graph and that was beautiful.
Doesn't it have to be
Whoa.
negative y?
Negative y.
Okay. What did you say?
Negative x.
Now, is it this or is it this?
Oh.
No, we don't.
Without.
Lisa does
Because
not like the parentheses.
if it's with the parentheses, it would be a positive x.
Exactly. Good call. Good call.
Oh, host.
Now, someone else suggested that maybe the negative goes here.
You were very smart.
No.
It could.
One more time. Say that again. Still the same.
It's still the same.
Suppose-
What?
Suppose we wrote it like this.
Mm-hmm.
What would happen if I multiplied both sides of this equation by negative 1?
Well, it'd be negative X squared.
If I multiply both sides of this by negative 1, this becomes a positive y, and this becomes a negative x squared. So it would end up being the same. We like this way because we usually like functions where it's in the form of y equals, and then everything else is on the right side.
That's the best way to go.
Totally, yes. Absolutely.
I've had the
This is the
experience.
right way to do it. We put everything on the right.
Right.
Okay.
The left way is the
Yeah.
lengthy
So
way.
here's the what we call the parent function, which is the most basic equation that will give us this shape of a parabola.
What's this one?
Then the question is, okay, what can we do with this shape? With a line, what can we do with a line? We can change the slope, right? And we can move it up and down. Right? We can change the slope, we can change the intercept. With a parabola, we can have it open up or down. We can have a parabola that, you're about to miss a visual here. Eyes up here for a second, please.
Paul.
You're working hard. Okay. If we have a parabola, is this still a parabola?
That is totally.
Yes.
What about this?
Yes.
That's
Okay. What about this?
That's
Yes.
a parabola.
Still a parabola.
What if it loops?
So then it wouldn't be a parabola.
What would that be called?
I'm not sure what kind of loop you're talking about. So.
Like a loop that like goes and then loops like an 8 snake thing.
It would take a couple of things together to do that. Yeah, keep it simple. This is Algebra 2. No.
I got the mind of a calculus brain.
I'm just going to let the audio speak for it. All right. So we can have it open up or down. We can change. We can make it a wide parabola or a narrow parabola.
A Z.
We can also move it. Right.
Let's move it to the left.
You can move it left, right.
Right.
Oh yeah,
Move it down.
we can do that sometimes.
Okay. So there's more than, so we can move it left, right, we can move it up, down, we can make it open up or down, we can make it open wide or narrow. The things that we are going to worry about in this class is we're going to put things into this form. So we're going to do it in this form here.
That is a nice.
So this is what, you're going to want this on your formula sheet.
Oh.
Hey.
Dang it. I'm sorry.
Good. The main thing that you need to know is that the vertex, the coordinates of the vertex are at h and k.
Where'd the orange go?
It
It died.
died.
It's my favorite.
So the vertex is the tip right here. You know, right where it reaches its peak. If it's open down, it's where it reaches the highest point, or if it opens up, then it's where it reaches the lowest point. That is called the vertex, and the coordinates of the vertex are at h and k. And then A is a number that has to do with how narrow or wide the parabola is. What you need to know about A is
Is vertex only where it reaches the lowest point, or is it lowest and highest?
well, it depends. If the parabola opens up, then the vertex is the lowest point.
Okay.
If the parabola opens down, then the vertex is the highest point. All right. If A is positive, then the parabola opens up. If A, let me just say positive. If A is negative, then the parabola opens down. Let's see, what else do you need to know? One more thing. A parabola, let's do another color.
We're on now.
One more characteristic of a parabola. It is symmetric. Right on top. Okay, pretend that's right on top of there. I just don't want to mix my colors. Parabola is symmetric. One half looks exactly like the other half. And we call whatever line that is the place where it mirrors one side to the other, that's called the axis of symmetry. So the axis of symmetry is the line x equals h. So this is what you need to know about the equation of a parabola when it's in what we call standard form. This here is standard form. Standard form for the parabola, for the equation of a parabola. Okay, so let's take a look at a couple of these. Oh, I forgot to tell you one other thing. general form looks like this. The general form is where you just multiply everything out. And you just have your x squared term and your x term and then whatever number there is. And when it's in general form, the y-intercept is at is at c. All right. So what does this look like? Let's clear some space on the board.
I don't get the what's the difference between standard and general besides the equations.
That's exactly the difference. You'll see it as this here.
Okay.
All right, what do we do?
Blue.
Blue? Okay. All right, let's do an equation here. All right, let's do y equals x minus 4 squared minus 3. Now, some of the things we want to figure out here. We need to know, does this parabola, if I want to graph this parabola, no. If I want to graph this parabola, what do I need to know about it? Well, let's see, I need to know, among other things, does it open up or down?
Down. Up.
Up. Because when the equation is in this form, the number in front of these of this parenthesis, if that is positive, then it opens up. Negative opens down. There is no number here, which means that it's 1, right? And there's no sign, which means it's positive. That's the way things are. If you don't specify that it's negative, then it's positive. So it's positive. So we know that this parabola opens up, like that. Where is the vertex? Where's the vertex? Remember that in this form, the vertex is at h and k. Let's do the easy one first. What's k? -3. Now, what's h?
16. What?
No and no.
16.
No.
It's 4.
4.
What? Wait, it's expensive.
Because look at the form. If we have x minus h in the parentheses, and the x coordinate of the vertex is h, here we have x minus 4. X minus h. H is 4. So you got to pay attention to the signs. Because notice here, in our standard form, it's x minus h, and then squared, and then plus k.
That's calculus
So
for
you
you.
gotta be careful on that. So our vertex is at 4, -3. So we go 4 to the right, 3 down. Where's our axis of symmetry? Looking right here. Axis of symmetry is the line x equals h, and what's h? One more time.
4.
4. So, and our x-axis of 4, our axis of symmetry is right here. So we know that right here, the parabola is symmetrical around this line. All right, what else do we need to know? For our purposes, now since we're just learning parabolas, this is good enough for now. If we have this dot here, we know that it's going to open up. So kind of like that.
That's cool.
All right. All right. So let's take it one more step beyond this. What if they give us the equation of a parabola that is not in standard form?
We move
Then
it
we
to
need to put it in
standard.
standard form, and the way we do that is by completing the square.
No.
Yes, it is. That's how we do it. Okay.
F.
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 No, 3.
No.
Or possibly. All right, need a color.
Blue.
Black, how fitting. Okay. Example 100.1. We need to, it says, complete the square to graph y equals x squared minus 4x form or general form? General form. Now, general form does tell us something interesting. What does general form tell us?
Y equals C.
Okay, it tells us where the y-intercept is. The y-intercept is right here. So the y-intercept is at 2. That means that the graph of this parabola will cross the y-axis at 2. Okay, that's useful information. But the rest of the information, and we could also determine that, by the way, follow me over here. In general form, this A is the same as this A. So even in general form, we can tell whether the parabola opens up or down. Does this parabola open up or down?
Up.
Up. So we also know that this parabola opens up, because that is positive, so we know that it opens up.
Yeah.
So it opens up, looks like that. All right, so we know two pieces of information now, just from the equation in general form. But we need to get it into standard form so we know where to put the vertex. Oh boy. So here's what you do. You need to, we're going to complete the square on this right here. Should probably do it in a different color though.
Pink.
Not pink.
Orange.
Red and orange. Yeah, red and orange are two colors I don't have. Okay, I'll pick. Let's do green. All right. So step one is going to be we need to group x squared and x terms so that we can complete the square. Complete the square. Okay. How do we complete the square here? You remember what to do?
Yes.
Take the coefficient of the x term. So negative 4.
Times 1/2.
Yep, times 1/2 or divide by 2.
Squared.
Either way. And we're going to square that, which is going to give us negative 2 squared, which is 4. And I should have done that in a different color. Oh well. Here, we'll make it blend a little bit, we'll use brown. Alright, so we take the coefficient of the x term, so negative 4. Divided by 2 is negative 2, and then squaring that we get 4. So 4 is what we need to add to complete the square. Right?
Right.
However, this is an equation. I can't just randomly throw in a plus 4 without balancing things out. Now, in the past, when we've completed the square, what have we done? If we add 4 to one side of the equation, what do we usually do?
Add it to the other
We
side.
usually add 4 to the other side. But we want to end up with a y. We want to have just the y on the left. What else could we do? If we add 4 to this side, we can add 4 to this side, or we could subtract 4 from the right side. So if I add 4 and then subtract 4, my equation is still in balance, right? Right? If I have an equation and then I add 4 and then I subtract 4, my equation is still true. It's a little annoying, but it works. So what we have here then is we have x squared minus 4x plus 4. Plus 2 minus 4 is? Yep, negative 2. Oh, black is trying to die too. End of the year marker blues. That doesn't count. Okay, let's try this again. So we minus, oh, look at that. Okay, so we have our y equals. We completed the square to get this, and the plus 2 that we had from before with the minus 4 that we had to put in to keep our equation balanced, plus 2 minus 4 gives us minus 2. Okay? Now what's the whole point of completing the square? It's so that we can take this and write this as x minus 2 squared. That's the whole point of completing the square. So we can write it as x plus or minus some number, in parentheses, squared. And we still have the minus 2, and we still have the y equals. But now we have it. What? Yes, but now exactly. Now we have it in standard form. Yay. With the y y-intercept is. We already know that it's going to open up because A is positive. Now that we have it in standard form, we can find the vertex. What's the vertex? Well, the vertex is a point which has coordinates.
So 2, 2, negative
Oh, okay,
2.
hold on. Let's do the easy one first. What's K?
-2.
Negative 2. What's H?
2.
2. Remember, the form is x minus h. So h is 2, and then it's plus k. So k is negative 2. All right, let's put this all together now. We've got our vertex, which is right 2 and down 2. So here's our vertex, which, by the way, once you have the vertex, the axis of symmetry is always goes through the vertex. So you don't even have to really think about that one much. So there's our vertex, axis of symmetry. We know that it opens up. Where does it cross the y-axis? What's the y-intercept?
2.
Yep, we got that way up here. It crosses the y-axis at 2. So we do know that at 1, 2 up here, we know that it crosses the y-axis right here. And since it's symmetrical, if I went left 2 units and up 4 to get this point, that means going right 2 units and up 4. I'm going to have, this point has a mirror image right here.
Okay.
And now I have enough information, so I know that it opens up, I know this is the tip, I know these 2 points, and so I can just sketch my graph like that. And we have sketched the graph. I know it's not exact, it should curve a little bit more down here, but we have the basic idea. I'm not looking for perfection on these graphs. I just need to know, did you figure out whether it opens up or down? Do you have the vertex in the right place? And you have, does your sketch look reasonably close? Now, one more example, because these are a little bit more complicated if it's negative. All right, let's match colors here. Example 100.2. If we have y equals negative x squared plus 2x plus 2. All right, what do we know? Does it open up or down? Okay, we know from this that it opens down. Opens down. What else do we know?
The y-intercept is 2.
Okay, we know that the y-intercept is 2. So it crosses the y-axis at 2, and it opens down. Okay, that's the information we can get from general form. Now we need to put it in standard form by completing the square. I forgot to write down over here. Keep equation in balance. Okay. All right. So what did we do? We're going to group the x squared and x terms. So we've got our x squared and x terms. So we got those together. We have the y equals. Let's leave a space and put a 2 over here. When we complete the square, how do you complete the square if you have a negative x squared term?
You move it.
Kind of a trick question.
You add a positive to it.
Yeah, we got to get rid of that negative. To complete the square, we need the x squared to complete the square. We need the x squared term to be positive. That means we need to factor out the negative, but that's going to change this sign also.
Okay.
Yeah. Okay, so we still have this stuff here. Now we can complete the square. Close. Alright. So let's complete the square. I'm going to do this in a different color. Let's do purple. Alright, so how do I complete the square? Take the coefficient of the x term. Take the coefficient of the x term, divide by 2, and square that. Alright, what's negative 2 divided by 2?
1.
Negative 1, and that's being squared, and so that is 1. So 1 is what I need to add here to complete the square. but I have to keep the equation in balance. What do I need to do?
Add
What?
one.
Yes, she said add 1. No one else volunteered anything else.
Why would you add? Oh, because the negative makes it.
Exactly, and that's what makes these so tricky. If you need to, make a note to yourself on your formula sheet where you're writing down these steps, because you are doing that, right?
Yes.
Yes. Whenever you're doing this on a parabola that opens down, that has a negative x squared term, you have to factor out this negative. You complete the square inside these parentheses, and so even though I wrote down plus 1, what effect did that have on the right side of the equation? I wrote plus 1, but that's inside parentheses that are being multiplied by a negative. So even though I wrote plus 1, what happened to this side of the equation? It went down by 1. So to keep the equation in balance, I have to add 1 to that side of the equation. And it's going to look really confusing to you that you have to keep the equation balanced by writing plus 1 and plus 1 on the same side of the equation. You have to bear in mind this negative here. And the reason I'm taking this long to stress this is that this is one of the most common ways for a student to mess up this kind of a problem. So watch out for it. Okay, so we've completed the square. What do we have in parentheses?
Negative 1, x.
Yep, x minus 1. And we still have this negative out in front. We have y equals plus 2 plus 1 is now plus 3. And now we have it in standard form, and where we can find the vertex. What's the vertex? 1 and 3. Good job, you're catching on. So now we can move on to graphing it. The vertex is at 1, and then up 3, our axis of symmetry, which I've been doing in blue, axis of symmetry. Pretend that went through 1. There we go. Axis of symmetry goes right through there. What was our y-intercept?
2.
Our y-intercept was at 2, so right here. And if we put the mirror of this point, we'll have another point right here. And now we can graph our parabola. Vertex here, it opens down, goes through these 2 points, so it looks something close to that.
Cool. Beans.
Okay, a lot to digest. Make sure you have all this information, and you probably want to write these steps down. Little star here, watch out for negatives. So make sure you have these instructions for completing the square and all the characteristics that I gave you over there on your formula sheet for parabolas. And that wraps up the video.
Good.
Have a schmappy day.
Bye.